Hello there, this is our video on James Chadwick. Please take out your handout so you can start taking notes. Sir James Chadwick was born in 1891 in Bollington, England, and he died in 1974 in Cambridge at the age of 82. He's an English physicist and he is known for discovering the neutron in 1932. The neutron is a subatomic particle with no charge but with a mass nearly equal to that of a proton. Now let's talk about Chadwick's life. In 1911, he graduated from the University of Manchester, and Ernest Rutherford was a professor there at that time, so he was Rutherford's student. Chadwick studied beta radiation with Hans Geiger in Berlin. And Geiger, if it sounds familiar to you, it's because he had recently, well, at the time in the early 20th century, Geiger had recently developed the Geiger counter, which is a device that measures radiation levels. While Chadwick was still in Germany, World War I broke out in Europe, so he spent the next 4 years in an internment camp in Berlin. In the camp, however, he had access to a lab. He was allowed to set up his own lab, and he kept on working with radioactive materials. After the war, he returned home to England, and first he arrived to Manchester, and months later he moved to the University of Cambridge, where Ernest Rutherford was the director of the university's lab. In the University of Cambridge is where Chadwick got his PhD, and later on in 1932 was when he discovered the neutron and was actually able to measure its mass. During World War II, Chadwick participated as part of the British mission in the Manhattan Project, which was the project that the US government had for building an atomic bomb. And he moved to the US. And after the Manhattan Project was done and the war was over, he served as an advisor to the United Nations Atomic Energy Commission. In 1920, Rutherford proposed that there were neutral massive particles in the nucleus of an atom. This conclusion came because he saw a disparity between the element's atomic number, which is the number of protons that equals the number of electrons, and the atomic mass of the same atom. Usually the mass was higher than the known number of protons present. So he started thinking that there must have been another thing inside the nucleus that was causing this excess mass. Now remember, Chadwick was working under the supervision of Rutherford, so Rutherford assigned him the task of finding out what was this thing that was causing the mass excess inside the atom. Here we have Chadwick's experiment. In 1930, Chadwick discovered that when beryllium was bombarded with alpha particles, it emitted a very energetic stream of radiation. Because these rays were not deflected upon passing through a magnetic field, then he assumed that they were neutral. When a beam of this radiation hits a substance that is rich in protons, such as paraffin, protons are knocked loose, and this knocking of protons can be easily measured with a Geiger counter. So, based on his observations in 1932, Chadwick proposed that this particle was actually the neutron that Rutherford was looking for, and in 1935 he was awarded the Nobel Prize for his discovery. Chadwick was also able to determine that the mass of this neutral radiation was almost exactly the same as that of a proton. Finally, we have Chadwick's model of the atom. We see that he proposes that the nucleus consists of both protons and neutrons, which we can see here. The neutrons have no net electric charge, so that means they're neutral. They're not positive, they're not negative, they're neutral. And finally, the neutrons have a mass slightly larger than that of a proton. And we can see here, this is a fair representation of Chadwick's model of the atom. We see that the nucleus already includes the neutrons, which are neutral, and that electrons are still floating around inside the atom, which is mostly empty space. So the mass is concentrated here in the nucleus, which is very dense, and we have protons and neutrons inside it. So this was our video on Chadwick. Hope you enjoyed it, and I'll see you in class.